grew up in a rural enough area, the Farmer's Almanac is what takes giant weather systems and things that we know about and stuff like the El Nino, if you've ever heard of that, and those different things, to predict what's going to happen with weather. And really why they care about it, why farmers care about it, is so they can determine what to do with their crops and when to plant and when to harvest and everything else. So according to that, this winter is supposed to be wet. If it's if it's cold, that means snow, okay, or ice. But it is supposed to have heavy precipitation according to Farmer's Almanac for whatever it's worth. Which I bet it's right like 50% of the time, which you could be if you just straight up guess. Right, so if something's right 50% of the time, people are like, it was right half the time. Well, yeah, it's so just a guess. But no, I think we are supposed to have more of a winter this year than we did last year. I know it was cold last year, but we didn't have much precipitation.
But how did they get that all?
Look into it. Look it up if you're curious. Like, not right now, but like we don't have time to teach about that right now. All right, we should have most of our classmates in here now. Is anyone interested in reading for us? And again, your group should have 2 books at your team. Your group should have 2 books at your team. Maybe opening the book, Simon, might help. Maybe. What page do we have? Somebody want to help us? What page you got? 384. Quinn, you said you wanted to read?
Yeah.
You ready for us? Or do you need time to organize your binder?
Yeah, because...
Okay, I'll start. If you get caught up, let me know. All right, guys, so in Chapter 5, which we skipped, but we did Chapter 5 stuff in Math 8 book, in CC3, we learned how to find the percent of a number by making a diagram to relate part to whole. If you remember these diagrams, we would sometimes use the hundredths grid, or we'd make our own and say, like, this is the entire thing. What is approximately 50% or 60%? Different ways we can model that, right? So this calculation is fairly straightforward. And we said percent of something. What does of tell me to do? Like when it says, yeah, multiply, right? If it says like 25% of the price off, or 50% of whatever, like of tells us to multiply. So, yeah, percents then can get difficult, right? Decimal percent values, or percent values less than 1, right? That gets a little tricky because if somebody tells you it's 1/10 of 1%, that would actually be written as 0.1, but then the percent sign. So if I try to write that as a decimal, it would be 0.001. It gets a little tricky. So today, we're going to use this sort of strategy. Hi, hey, you're walking in late. I'd love it if you didn't pick a conversation. That'd be great. Thank you. Alright, you guys got to get ready for the real world. You're going to walk into a business meeting late and be like, oh man, what are you doing tonight? Your boss will fire you on the spot. So, pick up at today, Quinn, and just take us home on that last paragraph.
Today we'll connect what you have learned previously about the relationship between distance, rate, and time to the idea of scale factor. You will learn how to use the scale factor to find the corresponding lengths of similar fact figures. This idea will add a powerful new tool to your collection of problem-solving strategies that will help you calculate percents.
We are now getting into geometry, which is a whole lot of fun because for you visual spatial people that are more into art or more into design or things like that, this is where your geometric brain gets to thrive. For those of you who are more algebraic, you still get to do that. No worries here. So, when we talk about similar shapes or similar figures like Quinn just told us about, that means it's the same thing, but not quite. Right? Same shape, but shrunk down to 1/40th of the normal size. Or same thing, but blown up to 400% of the normal size. It's the same thing, but of a different size, which means we're going to encounter this thing called a scale factor. So if you could please, on your notes, write down scale factor. Scale factor tells us if we're getting bigger or smaller. So if we have a scale factor of less than 1, if our scale factor is less than 1, like 1/2, 1/4, 1/8, this is a shrink. getting smaller. If we have a scale factor greater than 1, I'm betting that we can figure this out. What do? You bigger, we enlarge. So if somebody tells you your scale factor is 2, you double. 3, you triple. 4, you quadruple. So scale factor greater than 1, we enlarge. And a lot of times we will say this as enlargement or reduction. If you reduce the shape down, Mike, you got the stuff written down? Even the word enlarge? Okay. You just got it down quicker than everybody else. So, this same idea gets carried through in our distance, rate, and time problems because we have situations like this. So Dana's training for a bicycle race. He can ride 25 miles per hour, which is pretty quick. I keep track of my speed on my bike, and that's pretty darn fast. One day, when he'd been riding for 3/5 of an hour, he had to stop, fix a flat tire, right? Always sucks. How many miles had he ridden when he stopped? How do you know? So take like a minute. I doubt you even need that long. How many miles did he go? You probably only need like 15 seconds. Talk with your team to verify. So Quinn, what you were thinking about, you would divide by 10. You would divide by the denominator. I heard what you guys were arguing about. How far would that be, guys? 15 miles, right? Because if I take my actual number line here, which you wouldn't always be presented, but we know that he rode 3/5 of 25. I heard Quinn telling his group divide by 6 because he was turning his 3/5 into 6/10, which is in fact the same thing.
Well, that wasn't what I was trying to accomplish. What I was trying to accomplish was turn something like 60 into like a minute. I see that's not a good idea.
Oh, yeah, time gets weird to convert with. Be careful with converting with time. So if you would have divided by 6, then you would have gotten to 10 minutes every 10 minutes, but that, still 3/5 of an hour. That doesn't break down into a nice 10, like 10, 20, 30. So that if it was half of an hour, I totally support what you're trying to do. Figure out the 10-minute and then go from there. But one really easy way, this is multiplication, right? Fraction times fraction. Find a common way to reduce. So we've done this a couple times. I want you guys to start getting better at this. We can cross-reduce this problem and make life super easy. If I divide them both by 5, I get 5, and what's 3 times 5? 15. So this is how we can use that of turning into multiplication to make these problems a lot easier to solve. Instead of trying to multiply by a fraction. You can just divide and then do whatever multiplication's left over. So now we get into the geometry. So if we have two triangles that we have been told to be similar. So Matt's got these two triangles, an original and a new one. And the new one is 3/5 of the original. Would the new one be bigger or smaller? Smaller, right? Because it's less than 1. So if this was 25 miles or whatever distance, I guess length I was going to say, but distance is miles, then this just becomes 15. If that, my smart board's a little off. If this is 10 across the bottom, although I know that wouldn't make sense, what would my bottom of my new one be? 6, right? If I divide by 5, then multiply by 3. So think of 3/5, I gotta recalibrate this, times 10 over 1. 10 to the 5 can reduce, 3 times 2 would be 6. So I want you guys to look at 7-18 on your own. I'm going to recalibrate real quick and then just give you guys a little bit of time to work through. And actually, that one's probably going to be really fast because we already did that. So make sure you focus on C. You got to make sure you solve through those. I like fractions, for what it's worth. Just, announcement. I like fractions. That might relate to C. You should have books out. I have no sympathy.
Yeah, I'm okay.
Do a portions web if you want to real quick. You don't have to, as long as you know how to do it. If you're comfortable doing it, then that's fine. So, Quinn, there's your well, not your actually. We found out you weren't going that way, but there's the 6/10. If you guys want to take that way. All right, again, you can just do a little triangle on your paper when we're doing these. If you represent this expression in all three ways, 3/5 of 25. Or decimal, 6/10 of 25. Or percent, 60% of 25. Try C then. Scale those values. Get along with me today. I'll give you at least another minute to get through with these. We want to try to do these without calculators, right? We're able to do the work without calculators. We might as well. How can I represent 90% in the most efficient way to work with it? Howard? Yeah, but decimals are still kind of tough to work with sometimes. So you're right. You're not wrong at all. What Mallory said, I could do 0.9 times 25, but I don't even know what 9 times 25 is, and then I gotta make sure I put my decimal in the right place. Like I said, I like fractions, right? Percent means over 100, but 90%, if I remember, is just 9/10. Then times 25 over 1. Sorry that my 1's like in the wrong place. What is 25 divided by 10? 2.5, right? I just bumped that decimal place. Now, you can do it whatever way makes sense in your brain, but now, what's 9 times 2? What's 9 times a half? Yeah, sorry, my brain just got mixed up. 4.5, and then I can put those together. I hate that that's blue, but we're going to leave it. And it gives us 22. All right, I don't know what's going on. 22.5. 8% of 75. Now I could decimal, right? But then that becomes 0.08. George?
So there was just this was a trick that we were taught last year.
Yeah.
If you want to find, if it's like out of 10 or out of like a 1, it's what you did up there, but
Yeah.
you just move the decimal place over to the left once for 10%.
Ah, yeah.
And then twice for 1%.
So I'm going to explain what you're talking about in a different manner.
Yeah.
Like, what you're saying is awesome, but just so we can keep on the same strategy. What George is saying is if I wanted to find 1% of 75, you guys, this is a really good strategy. I see a lot of, like, eyes doing your own thing. George said, I can just move the decimal 2 places left because 1% would be division by 100. So what George is essentially telling us to do is end up with 8 times 0.75. Right? Because that's 1%. 0.75. That's 1%. So then, well, I can pair these up, right? Every 2 of those makes how much? 1.5, 3. I'll double that again. 6. And then live along the crossword. But, yeah, so this becomes just 6. Sorry, is it thumb in or thumb out? Yeah, I thought it was out. And then 25% of 144. How can 25% be made easier? Somebody else I haven't talked with yet, Olivia? A fourth. A fourth, of course. And then I'm going to break this. I like breaking things. Ask my wife.
Don't break me.
What's 100 divided by 4?
100 divided by 25.
25. What's 44 divided by 4? 11. Put those together. 36. Now, you could use a calculator. I get that. But we want to understand why we get the values that we do. So if we accidentally type something in wrong, our brain catches it and says, wait a minute. How could 8% of 75 end up with 60? Right? If I type in 1 decimal in the wrong place, I get my answer as 60 instead of 6. You need to have alarms in your head that say, wait a minute, this is less than 10%. That doesn't make any sense. Now, if it was 80%, then it'd be 60. Right? So if this was 80% and my smartboard's way off, then it'd be 60. Cool? Questions, comments, concerns, quandaries, queries,
I don't have any.
qualms, quarrels? A quarrel is like when you fight, like a. If you have a quarrel, you're having like an argument.
You mean if I have a quarrel?
Have I done the whole emphasis thing in this class?
No.
You know how like different people, I know, different people put different like when they say things they emphasize the word weirdly. I'm trying to think of a word that people do that with. But so my dad taught me this a long time ago. Said if you sadle or if you put the wrong emphasis on the wrong syllable, you can saddle up your horse and gallop into the quarrel.
What?
If you put the wrong emphasis on the wrong syllable, you can saddle up your horse and gallop into the quarrel. Now, with the emphasis in the right place, if you put the wrong emphasis on the wrong syllable, you could saddle up your horse and gallop into the corral. All the same words, emphasized differently. If you put the wrong emphasis on the wrong syllable, you can saddle up your horse and gallop into the corral. All right, so Josiah wants to leave a tip at the restaurant because that's what people do. Now, mainly only in America, because other countries, they charge you more and then you don't have to tip, which is kind of like you could make arguments on both sides.
People think that, like, tipping is weird, like, because
Yeah, other countries, yeah.
offending the waiter because they think that
Yeah.
it's offending them because
But
they
waiters in
don't
America don't get paid very much.
Yeah.
Yeah, so that's the issue. So, I would love to talk about that for a while, but we don't have enough time today. So, Josiah went out to dinner at the Indian restaurant. The total bill was $38. Now, I literally will smack the phone out of my friend's hands when they pull it out and try to calculate 15% for a tip. Like, no joke, get that out. I don't
Get
care.
that out of here.
Yeah, seriously. Like, you're surrounded with mathematicians, because a lot of us are like mathy, engineering type guys. So, now again, it's not just because I like to break things. When I go to do this, the easiest way to do this is break things into pieces. And I want to see if you at your group can figure out the easiest, most efficient way to find a percentage like 15%. Because if you were being really nice and tipping 20%, that would be easier, right? 20% ends in a 0. It's easier to work with. Da, da, da. I will give you a hint that George's method comes into play here. I'm going to try to figure out 15% based off breaking things apart, and George's method of decimal manipulation is going to come into play. I'm going to give you until the big hand's on the 10. So however many minutes that is, 2.5 minutes probably.
So you can, it's a 3, I guess.
You cannot use a calculator.
Will you smack it out of our hand if we do it? I want to see it happen.
You can use your brain, but you cannot use a calculator. You cannot long multiply either.
If I pull a calculator,
No, you cannot long multiply.
you can't long multiply.
Hey, I don't know why I have just like noises being made. We have a pass. Don't pay attention to what I'm doing.
I ain't paying attention.
I'm just not, it's not going to help you. Trust me.
I've broken it in 30.
Okay, this is like I'm growing to 50%, 5%, and then so I divided 38 by 10.
30 seconds.
30.8, and then I can just combine that by 2, which is 1.
Gabe Hosmer. Can I volunteer you to explain this to the class?
Sure.
In like 20 seconds, once I give the time that I said I would. Well, now everyone got quiet. Now it's awkward. Well, now it's awkward. I always felt like that at church, occasionally. Like we're going to take a moment of silence, and then it just goes on for too long. And they're like, well, now it's awkward. And they're looking around, and you see the people who are like 60, and they're looking around. Your eyes should be shut. My eyes should be shut, too, but your eyes should be shut. All right, Gabe. So I'm doubting that you memorized 15 times 38 in your multiplication class, right? So Gabe, explain to us what we're going to do here.
So since, 15% equals 10% plus 5%. So if you can find 10% of 38, that means you can divide that by 2 and get 5%. So
How do we find 10%?
you divide it by 10.
Yeah, and that, as George told us, we just bumped the decimal, right? So if my decimal's right here, which I hate when they, like, there should be a period and a decimal, kind of, maybe, technically, because it's money. But, so 10% is $3.80. Easy enough, but tipping only 10%, not cool. Should at least tip 15, even if the service was meh. So then what do we do, Gabe?
So then you can just divide that by 2, since 5% is half.
Yeah, this is half of that. Cut in half, cut in half. What's half of $3? $1.50. What's half of 80 cents? 40 more cents. So I get $1.90. Put those together, and what? $5.70. So if they were being really nice, round it up, just tip $6. Now that is an interesting human psyche thing that we like to round things off to the nearest dollar, which is also fun math fact for the day. Why it is a human condition strategy to put prices at 95, 96, 97, 98, 99 cents.
I,
Because your brain says, well, it's not $40, it's $39.98. Okay, it's $40, right? It's not like, it's 40. But your brain, seriously, this tricks your brain. So try to retrain your brain that 99 cents, like, that's the next dollar, really. Yeah.
my parents told me why it's 99, like 39.99.
Yeah.
Yeah, my mom already
It's
told me.
because some person's newspaper went for like a cent,
Okay.
but it was a really good newspaper, but people just never had the cent on them.
I don't know that that's true. That might be true. That could be, like, so then they put another price of something at that, like, then I'll make the coffee, like, whatever, so you have a, but, like, if the newspaper was 1 cent back at that time, I don't know what they could have charged, like, 99 cents for. You know what I mean? Like, if I'm paying a cent for a newspaper, I'm not paying 99 cents for a cup of coffee. Like, that'd be a lot of money. So that's the only reason I'm skeptical, because it is also, even if that's true, which it could be, it's also to trick your brain. That's the main purpose. Or when they're like, for just low 3 payments of $19.99 and 2 more payments, it's sort of like they try to trick you, right? Because they're breaking things apart. What if Josiah decides that the service is really good and we're going to leave 20% instead? How can we still use George's method to get us there, Savannah? Yeah, somebody said this, we can just take that and double it, right? Once I have 10%, it's easy to work with. Now, the other thing I could do from 380 to get to my 5% is I could find 1% is 0.38. 8 looks weird. And then I could multiply it by 5. That, in this case, I don't think is as easy. Depending on the numbers, sometimes that's just as easy. Like if this was 40 cents, well, 4 times 5, that's easy. So it all depends on what the problem is.
Wait, is it really better to have a 30% tip?
That would be like really good service.
Is there also like 90% tip?
If you were really, really generous and just trying to make somebody's day, maybe.
You're much likely to get paid up.
So there, I've seen like one instance, and I'm sure there's been other ones, but one of my friends actually, I think still works at Texas Roadhouse as like a manager or something. But he once had like a $55 or $60 like bill, like what the people needed to pay, and they left him $100. And that was a huge tip because they tipped almost as much as the meal was. But they like wrote a note of like and he like talked with them and told them his story about how like he went to college and had a bunch of student debt and he was trying to finish up college and like he just was personal with the people and they like they had the money to leave him, so they left him a really nice tip. Actually, he's a nice guy. He's like a teddy bear. He's really like, yeah. Yeah. Yeah, everybody at some point in your life should work at a restaurant to appreciate what it's like to be the person working at the restaurant. Simon, then we got to get back on task. Yeah.
I forgot exactly where it was.
Hey guys, Simon's talking now. Let's have some respect.
Where it was, I think it was like kind of a small family business or something.
Yeah.
But the guy said for a low price of $100.
Well, it depends on who you are. That might seem like a low price.
Well, like if you're buying for a car, it was for some product. It was like $100. The product didn't even seem like it should be worth $100.
Yeah. Well, and that's supply and demand, right? Is the consumer willing to pay that? So Isaiah's shopping for a new computer game, right? And like a lot of you guys, or Xbox, or whatever you want to say, new game. It's new game day, right? Now, GameStop. Yeah, I'm hip with the times. I used to go to GameStop. GameStop's normal pricing, at least back when I used to buy games, are they still like 50 or are they like 60? 60? Okay. So let's say it's a game that is $60. Okay? But they know that's expensive. Right? Stores do this on purpose. They jack up the price so they can be like, look, we're on sale.
Yeah.
So your group, I would suggest using the George method. Your group needs to figure out what is the sale price of this game when it is 35% off. You can either use the George method, or actually I think this is kind of the same, or you can use 35 over 100, but you need to figure out, like, is just multiplying by 35 over 100, does that get us our answer? Is there anything else to do? We have a few minutes left. We've got plenty of time. I'll probably even get us out of here early for lunch. How do we figure out that discounted price? So I'll give you guys like 2 or 3 minutes to solve this. You got a few different methods to choose from.
Alright, I like it. 21.
Just kidding.
I like to see how you guys think. The original 60. So I'm changing this problem a little bit. So really what the problem is asking us, though, is what to use here. Isaiah thinks he should use the scale factor of 35 over 100. But does that get, so forget about this. The games aren't $40 anymore. I wanted to make it a different number. So ignore C.
Nintendo eShop games, they have like Super Mario Maker, that's for $40.
Okay, so, but I like the number 60 here, like, for specific reasons. So, if Isaiah says, guys, I know how to find the price of my game, it's 35% off, I just multiply by 35 over 100. Will that work? Anyone have opinions for me on that? Will that work?
I found a quicker method that I didn't.
Well, hang on, because that's not what we're... So the question I'm asking is, will what he says in A, will that work? Chloe? Ah, so if he only multiplies by 35 over 100, he's just finding the amount off, right? Not the new price. Now, if I take the George method and I just first find 10%, bump the decimal over, that's $6. Right? So every 10% is $6. So what would 30% be? 18. Okay, so stick that somewhere. It's a working number, right? Either in your head or on your paper. Then what would 5% be? 3. So 21. But that's not the price of the game. That's the amount of discount. So to finish this out, yeah. What did you do to get there?
I found out what 10% was.
Yeah.
Then I multiplied it by 30. Then divided it in half the 10%.
Right. And we got our 21, but I'm just looking for one more word. What'd you do to get to the 39?
I subtracted.
There we go. We just have to subtract away the sale. Right, so we subtract the sale. Now, what other way could he use to get to the sale price arguably more quickly or just as easy? Brennan? Braden! Dang it, I knew it as soon as it came out, too.
You could find 50% first, which is 17.5.
Okay.
And then add 10, just 1 over 10 times 35 over 1, which is 3.5, and you get 21.
I agree, but you tried a little bit too hard here. Everything you did was fine, but we want to be efficient, right? George, is there another method?
Yeah, so instead of trying to find a sale price, you would do 100 minus 30s. 100 minus 35 give you 65. So you find 65% of 60.
65% is what we have to pay, right? So if I multiply my 10% by 6, I get 36 plus that $3 still, I get my 39. You're good.
Just a reminder, Discovery Day rough drafts are due in the hallway basket.
That didn't, well, we're close to it now. Try that again if the game is $40. So now the 40 that I crossed out, try a different method than what you did last time is what I would encourage you to do. Try a different method than what you did last time. So if you found the discount and then subtracted, try to go the other route. Find the 65%. If you found the 65%, go the other route. Find the discount and then subtract. What's our 10% here? $4. What's our 5% here? 2. So 60% would be 24, right? Plus another 5% is another 2.
$26.
This would come out to be $26.
I was so.
I have some papers to hand back. I will get you your other tests tomorrow, probably. I just need to get them in map. You probably noticed that your 2-3 tests are in map now. So this is like revisions and homework that got turned in randomly. You will get your 4 or 5 tests back tomorrow. And then, I'm debating if I'm even collecting it. Because if you get it, you already got your benefit from it. Like, all I'm saying is I'm not sure that I'm going to make you guys turn in your homework. Am I crazy or is Maren not here? Is she in the wrong place? Because who isn't here either?
Yeah, I think Mr. Estes,
Okay. Yeah, you guys are good. Now make sure your rough draft is turned in the hall.
Who's Thunder? What?
Read the back of that.